Okay, and Kathy, if you're ready, I'm going to go ahead and turn the screen over to you.
Okay.
Okay. And there you go.
Now I'd have to hit show my screen correctly. Correct
Yeah.
here? All right.
That looks great.
Oh, thank you. Well, welcome everybody. Thank you for joining us this evening. I see a few more people popping in. And I actually see one of the participants who was in the online TinkerPlots course. So I want to give a shout out to Ruth Ann. Thank you for joining us tonight. We just finished up the first online TinkerPlots course. So I believe there was a slide in the startup information about that. And I believe the next course is going to be offered in October. So if you're interested in that, you can check that out on Key's website. Well, let's get started by getting to know who's in our audience tonight. I'm going to put a couple polls up. So I'm going to, let's see, let's start out by finding who is here. What is your teaching experience? So I'm going to launch a poll here and ask that people click on one or more of the options that are showing on your screen and then click the Submit button. And when we get close to the majority of people voting, I'll close it and we can see what we have. And just a few more seconds. I think I'm going to go ahead and close it. Sorry if I missed you. And I'm going to share the results so we can see what we have. Okay, elementary 36%, 7th through 12th grade, that's our middle school and high school, 73, and teacher educators, 36. Okay, nice rounded audience. Thank you. Let's put another poll up and see. Let me hide this one and let me go to another poll. This one's going to ask about your use of TinkerPlots. How familiar are you with TinkerPlots? Have you never seen it before? So again, if you could pick one of these. And click Submit. And I'll kind of watch and see as people are voting. And then I'll show the results. So again, we can see who's with us tonight. And if I start to go too fast and I see something come into the chat pod from my partner, Mark, I'm going to go ahead and unmute him or have him unmute himself because I don't want to go too fast tonight. That's not a good thing. So let's show those results. 50% have never seen or used TinkerPlots before, and 36% have used it a little bit. Demonstrations and with students. Okay. Very good. Excellent. Let's put one more poll up because part of our focus tonight is to talk about a connection with the Common Core state standards. So I'm going to throw this one up and let you vote real quick. I have an alarm going off on my phone, so I apologize. Hopefully I didn't step away for too long there. Turn off these alarms. And we'll show the results here. So 70% have the Common Core standards in their state, or they are coming soon. And a few people aren't sure, they don't have the Common Core standards or don't need to follow those. So that gives us some information about who we have in the audience. Thank you very much. And from here, I'm going to hide that one. And I'm going to actually hide my screen because it's covering up some things. There we go. I want to introduce what we're going to do tonight. I have 3 parts to the webinar. The first part is where I'm going to just briefly introduce measures of center and then talk about measures of spread, and those are the ones that we've been probably most familiar with in the past, and that would be range and interquartile range. And we'll look at a number of different TinkerPlots tools to show range and interquartile range and some different box plots and different hat plots. In the second part, we're going to get into the mathematics of the mean absolute deviation. And then from there, we're going to go back to the full data set and talk about the mean absolute deviation. So let me go ahead and get started. This data set that I'm using is called Backpacks, and mine is called Backpacks Master just because I had so many different files going on, I had to rename it so I didn't lose it. This would be a nice activity for you to do with your students because most students carry backpacks. But I want to talk about the sampling that was done before we get started because design in your experiments are important, and when you're surveying, you can think of that as an experiment. If you go into a school and you start to survey the students, it's probably not random sampling, it's probably convenient sampling or cluster sampling. And in this case, we don't really know what the sampling method was, so I'm going to assume it was either convenient sampling or cluster sampling. Because I see data for first graders, third graders, and fifth graders, and I'm reading it in the text box here. If I go through the cases, we see that we have females in first grade. If I click on a data point, it's going to take me right to that card. So this is Josh, who's a male in third grade. And it's giving the body weight, the pack weight, and the percent weight. This activity is, there's an activity for backpacks. It's available on the Key Curriculum website. And it talks a lot about percent weight. And are students carrying a backpack that's too heavy for them? And the guidelines, I think, are 15% of their body weight. One thing that I want to caution people about is if you were to do this in your classroom and you're asking students their body weight, you might get in trouble. Because if you have a very small child or a very large child, they may not want their weight to be known to their classmates. And they may feel pressured to get on the scale and you not know it until you get a phone call from mom or dad. So you might want to have them weigh themselves in private and let everybody know that the kids can either give their own information or they can give fictitious information. We need to be really careful with any type of surveying that we do to collect real data where certain students can be identified. So I think that was, this is a great thing to do with your kids, but also be careful. Now I'm going to actually delete body weight because I don't want to use it. So I don't really want it to even get in the way. So I'm going to delete that attribute and I'm going to delete percent weight. So let's take this one out as well. So we're going to delete those. So now I'm down to just pack weight, grade, gender, and name. And let's get started. We're going to look at measures of center first. I need to click on pack weight. We'll look at some measures of center to just get started. So notice I dragged an icon to the right. Usually if you drag a darker one to the right, things work the way you want them to. I'm going to click on stack. And there we have a dot plot, or what NCTM calls a line plot. And let's look at some centers, because we need to pay attention to the context if we look at Common Core. You can't talk about variation until you have measures of center. So I'm going to throw these three up there. So we have the mean tool, the median tool, and if you pull out down this drop-down arrow, you have the median tool. And I'm going to show the numeric values there and talk about this data set. What do I see? I see a clump right here and I see a couple potential outliers. And we're defining outliers as values that just don't fit the rest of the data. So not for sixth graders, not to begin with. We don't want to worry about the formal definition, but just an informal definition that those points just don't seem to fit. But we also see that this data set is skewed. The outliers in this clump are pulling the mean up. Our median is at 8 and our mode is at 7. So here it would be a nice time to have a discussion about, well, which average would be the one that we want to use? And if we want to make the case that the kids are carrying backpacks that are too heavy, we probably want to go with the mean. If we want to say, well, what's the most common backpack size, we would go with the 7 pounds. So just to kind of get us used to the data, I wanted to show those. I'm going to now turn those back off. and do some things with variation. So where do we want to go with variation? Let's start with looking at some of the hat plots that we have here. A 25 to 75 percentile hat plot is going to do the same thing as a regular box plot. So notice if I switch this to a box plot, they're exactly the same except for what? The median goes into that. So let me put the percentile plot back up. But they are different in TinkerPlots. We can actually change the brim of this hat. So if you have an application where you want that to be different, you can actually drag either side of the crown and change that. So I want to show that. We also have a range hat. So I want to put this up and see if anybody has any questions about the range hat. What is going on here? What is in this middle part, and what are in the brims of this range hat plot? 33% to 67%. I want you guys to stare at that for a minute. I'm also going to put a ruler up here. Our first measure of variation is to find the range. So I'm going to snap the ruler to the minimum value and the maximum value. And what I'm going to show the overall range is 36 pounds. The other thing that I want you to notice, well, the thing I want you to notice with this range hat plot is it's actually taking the range, it's looking at the range and dividing the range values into thirds. And if I throw a reference line up, I don't know how many of you have ever taught mean, what do we call it, mid-range. If I eyeball this and go into the middle of this range hat plot, I'm going to get the 21 pounds, which is mid-range. So not something you might have expected to see in TinkerPlots, but there it is. And I'm going to turn that one back off. And I'm going to go back to let's go back to a box plot. So we have a range of 36 pounds, but is that really accurate for this particular data set when that 39-pound pack is an outlier? If I move my ruler tool to the ends of the box and whisker plot, TinkerPlots, the ruler tool, will show me the interquartile range of 9 pounds. Well, this is a good starting point, but we're only looking at one attribute. We're only looking at pack weight and for all of the students. So let's split this out by gender, by dragging gender to the y-axis. And now let's look at some comparisons between the two data sets. Would range be a good indicator of variation? Would it be true to say that there's more variability in the females and their pack weights than the males? What do you guys think? Is there more variability in the females or the males? Because if I go out here and look at this range, that's quite large. But is it true that the females have more variability? And I think you would agree that it doesn't. If we start to look at interquartile range for the females, we get an interquartile range of 8. And if we look at this for males, what do we get for the interquartile range? It's going to be larger. So it's actually 10. So that's kind of interesting. So I'm going to stop just real quick because I'm seeing some questions going on the other computer screen. Somebody wants to know if they can add a data card. And yes, you can. Let me show you how to do this. If I get all the way to the end of the data cards, maybe if I go back to the beginning, if we get to the end of them, you'll see a blank data card. And I'm not sure how to zoom to the end, so I'm clicking through. If I click all the way through to get to the end, I will be able to add a new data card. And there it is. So you can add the student, the gender, the grade, and the pack weight.
And Kathy, there was a suggestion in the chat pod about possibly if you wanted to use this with students, excuse me, and use their data, that we could possibly not record their name, and that might protect the identity of the students.
Sometimes it will, but sometimes if you have an identifier of weight and you have a student where just by looking at the student you can tell what their weight would be, then you have to be really careful. But yes, in a lot of cases, changing names will mask the data.
Are we able to hide that attribute once we've figured our percent weights that we needed, or even hide the?
You'd have to filter it.
Okay.
I'm not sure if you could hide it. That's a good question. Very good question. It is important when we are looking at finding that percent weight. It would be important to have the person's actual weight, but it becomes a matter of being very sensitive about the data if we actually show that to everybody. So, so some good questions, some good things to think about. Changing names might work. So good thinking. I'm going to go back up here and look now at a different way to divide this data up. So let's look at grade, because I think you guys agree that the difference between the genders, there really wasn't much difference in the variability. So let's look at pack weight for the first graders, third graders, fifth graders, and seventh graders. And here I have the box plot. I'm keeping the box plot up there. And again, I'm focusing on two different measures. I'm looking at range and interquartile range. So here we have a 2-pound interquartile range. If we move this up to the fifth graders, we'll see a larger interquartile range, so there's more variation. If you look at the range, there's more variation in the range. So it just depends on which number you think is giving a better representation of the variation in the data set. Another thing I want you to focus on is the ratio here. So if we visually look at the third grade to the fifth grade, it looks like it's almost double. And if we go from third grade to the seventh grade, it's at least tripled if we look at the overall range. Maybe not tripled if we look at, well, maybe it is tripled if we look at the interquartile range. Let me think if there's something else I wanted to do here. And I think there was one other thing that I wanted to do here before we go off this main data set. We've talked about range. We've talked about interquartile range. We haven't really talked about where these box plots come from and maybe some of the misconceptions. I don't know about you guys, but when I have a really long whisker, my students will say, well, there's more data out there. And if they're thinking about a histogram, histograms do have more data where you see longer bars. But in a box plot, that's not true. So I'm going to mix this up. And since we're talking about variation, we're talking about box plots, I'm going to go back to a regular dot plot here. And I'm going to throw some dividers up. And I'm going to set this to 4 because I want 4 dividers. And I'm going to try to sneak up on that 4-number or 5-number summary by asking myself to visually divide this data up into 4 equal groups, just by estimation. So one of the things I'm trying to do is follow the mathematical practices, our standards from the Common Core State standards of modeling and problem solving. So I'm going to turn on the count here and see how did I do. Well, if I have 26 in this section, that's probably too much. So let's move that one down. I'm trying to come up with 4 equal groups so I can estimate where that box plot is going to go. And this might be a helpful activity. I was actually going to try to line my students up and make a human box plot today in class, but we didn't have time. I think where people get stuck is when you have a whole bunch of data points together where that quartile is going to change. So obviously we need more than 14 students in that first quartile. So we need something like 6 of them, something like this in our first quartile if we were to divide this evenly. But because we have so many 5-pound packs, we can't show exactly where the quartile 1 starts and stops because it's happening right between a couple of those data points. Well, let me see how I did. And you can, just real quick, you can clear your drawing if you want to by going over there. Let me see how well I did. What do you guys think? If I put my box plot back up here, how did I do? Well, the 17 was obviously a little low. That one needs to come down. And that one needs to come down. So I was trying to sneak up on the 5-number summary there. So I'm going to pause here and check, see if we have any questions coming in. Mark, do you think I missed anything that I should be talking about?
No, we're doing good. I think when you first see the TinkerPlots here, it's good maybe to let people know that the white space, your attention's immediately drawn to the gray space, but that white space is also a group, one of the dividers. So we do have all 4 divisions there.
Oh, okay, yes. And the way you can see that, I think, is if you have this count turned on, you can see that. But it can be kind of deceiving when you throw that, when you initially throw that up, because sometimes it's all kind of smashed down to one side of the graph. Any other questions? Can you import data from Excel? You certainly can. You can import data from the internet as well. To talk you through how to import from Excel, you would want to have your data set up in columns. And once you have copied that into your electronic clipboard, you're going to highlight this case table, well, this case cards, go up here to Edit, and click on Paste Cases. And that will fill up your cards with the first row as the names and the rest of the data inside the cards. So that's a good. No, Payush, it cannot find kurtosis. I tried to check on that last time you were online with us, and thank you for coming back. I said it couldn't do it, and I did check, and I am not seeing that. So unless you want to put the program, put the mathematics into a table to find that, I have to say the answer is no. But I will show you some more things tonight about some of the statistics that TinkerPlots can do. So good question. All right, so I'm going to clear my drawing here, and I'm going to actually shrink this guy down all the way to a teeny tiny little icon, because screen space does start to tend to be an issue. So if I can get my mouse, there we go. And I want to use a smaller data set as I talk about mean absolute deviation, because 79 data points is a little large. So I'm going to actually copy this set of data cards. So I'm going to go over here to Object and say Duplicate Data Cards. And if it's okay with you guys, I'm going to actually delete this information table or text box and move this down here. And I need to bring in 2 plots. I'm going to start with 1, so Mark, remind me if I forget that second one that I need that in there. And what I want to do is delete some of the students out of this second data set. I want to show you a quick, easy way to do that instead of having to go through one by one and deleting the students, deleting the cards. I want to delete all of the females temporarily. And I'm going to hold the Shift key down, and I'm going to highlight the first graders and the third graders for the males. And let's see if this works. I'm going to pull a table down. Oh, I got to do that again. Pull your table down first. Sorry, guys. And let's do that again. Females, and well, let's make this easy. Let's move the first graders up. Females, Shift key, first and third graders, go to my table. Those students should be highlighted in this table, the ones that I selected. And now, when the table is selected, I'm going to go up here and say Cut Cases. So now notice I'm down to the 22 cases that are just the males in 5th and 7th grade. I am going to use this table because multiple representations requires that we pay attention to graphs and data in the tables. So we're going to look at some formulas as we move forward here. I want to pull down one more plot, and I'll make it rather skinny so I can get to the bottom of it. And you'll see why the second plot is here in just a little bit. So that looks good. So now we're working with the data set for boys. If you want to relabel your case cards here, you can click towards the top of it and relabel that, and that will change the labels for all of the graphs and tables that are attached to that particular data set of cards. Let's click on pack weight and create a dot plot up here. My goal for this second part of the webinar is to talk about the mean absolute deviation, and I want to show mathematically how to find it and illustrate it through the graph and the table so it makes sense. And then I'm also going to, at the same time, show how TinkerPlots will compute the mean absolute deviation. But I don't just want to have it kind of a black box effect where it just gives you the number. So the first thing that we have to do is focus on the words here, mean absolute deviation. So I'm going to start by finding the mean, because there's actually something hidden in this name. The deviation from what? Well, deviation means difference from the mean. So we have to find the difference from the mean. So we put the average up, and we're going to use our ruler tool again. The ruler tool can be snapped to the mean, and it can be snapped to a data point. And if some people, I think some people like to have their data points in order. If you want to do that, you can click on order here, and it's going to just reorder these so they're in order. And it doesn't make any difference, but as it goes through, you'll see why it might visually make a difference here. So what is the mathematics that we see? We see 21 minus 14.131, which is the mean. Oh, let's show that. Show numeric. There we go. And we get 6.68182 rounded to 6.7. Again, one of our Common Core standards mathematical practices talks about precision and when is precision important. Here I think you would agree that going to the 10th place is important. If I click on next, it's actually going to stay there and throw this measurement in because it just actually measured that one now. Now it clicked to the next person. But what's being measured? Let me slow down here. What does this icon mean? This is Tyson. Tyson has a 22-pound backpack. He's in the 5th grade. And the deviation from the mean for his pack weight is 7.7 pounds. If I click on next, we go to who? I'm going to click on the icon, and this is Jeffrey. He has a 27-pound pack, so the deviation is 12.7 pounds. What's going to happen next? It's going to flip over to the other side. So we get negative 11.3 pounds. So now our deviations are below the average, and they're negative. And notice how this is coming out in words here, which is really nice. It's, well, we get the numeric equation, and then we get the sum of the differences of the 4 cases. So this is a running total. Well, what do you think that running total is going to be when we go through all of these differences? Well, before we do that, we need to catch up with our table here. So I'm going to add a variable called diff to the table, and we need to add a formula. So if I highlight this whole column and show formulas, that's going to actually show the formula in this window here. If I right-click, I can get this to open up and show you the formula editor. And what do we want to do? We want to get this difference. So we want to take the pack weights, so double-click on pack weight, minus the mean of the pack weight. So I'm going to show you where some of these functions are located. And I've already opened some of these windows, so let me collapse this all the way. If you go to statistical and click on one attribute, you get all of the functions that you would expect to see for one attribute. So there's mean, and there's mean. You double click on it, and now it's saying, well, the mean of what? So let's go back up to the top and say, well, we want the mean of the pack weight. You can type all of this in, or you can click on the words that are in the formula editor. If you click on apply, it's going to throw it into the table, and click on OK because we're done. So let's just make sure that this is looking good. So if we find Larry, if I click on Larry, where is Larry? Larry's here. So let's go forward and see if Larry actually has a deviation of negative 6.3, and that's correct. We'll have this other plot down here. And what I want to make sure is that my students really understand that these values are important. These different deviations that we're finding, or the differences that we're finding, are very important. So I'm going to actually graph this below here. And let's make a line plot of it and stack this. And notice that the icons are almost the same color, but we have two different variables. So I'm going to change this because that's visually that's going to throw some kids off. So what did I just do? I'm not sure what I just did.
You cut your attribute.
Did I just get rid of it?
Oh, you cut. I don't know if you can paste it back in.
Well, let's just do Control Z. Always works. There we go. Didn't mean to do that. All right, what I'm trying to do is double click on the color, and let's pick red. And we're not going to stay on pack weight very long because, and you'll see why in just a minute, but I want people to really understand what these numbers are because of where we're going with this computation. So let's move up one here. So we are on Matt, and his deviation from the mean is negative 5.3. So where is Matt? Down here, and here is this value. So it's being graphed. So we kind of are following along with what is showing down here. So that's taking care of the first part of what we need to do to find mean absolute deviation. We found the differences from the mean. But if we want to take the mean of the total, we're going to be in trouble because this mean is going to come out to be a number that is going to be problematic. So don't blink because I'm going to clear this and I'm going to say measure all. We're going to come up with the sum here of the differences from the mean. So don't blink. What is that total? Well, it's 0 because it has to be 0 because of the way the mean is calculated. So we need to do something more here before we can take the mean of the differences. In TinkerPlots, we can change this so we can get the absolute difference. So let's look at what happens as I click through. I'm going to clear and I'm going to go through one at a time. 7.7, 12.7. Okay, who was this? Who was this guy? Chad has a 3-pound pack and he has negative 11, but what's showing up here? Positive 11.3. So the computer's taken the absolute value, which is wonderful. It's finding these differences as a positive value so we can add them all up. Let's do that in our table as well. Let's find the absolute value of the difference. In TinkerPlots, you cannot have any blanks in a title, so we can use the underscore here. And I'm going to double click in here and show my formula, which is basically taking the absolute value, which is shown on our calculator here. We want to take the absolute value of the pack weight. And here we do have to double click and click apply. And okay, and something's not quite right. Something doesn't look right. That is clearly not right.
Do you want to take the absolute value of the difference instead of the absolute value of the pack weight?
I put the wrong thing in there. Okay. You're right. I was supposed to. Oh, I'm getting tired. Sorry. Let's cancel this and try this again. Or not cancel it. Let me clear this. Okay, I want to take the absolute value of the difference. There we go. Okay, the absolute value of the difference should be just the positive value. Okay, and let me go through another one here. 8.31, 7.3. Everything's looking good. All right.
And Kathy, before we move on, there was a question about color. Can we go back up to the backpack boys at the top and lock that graph? Because when we changed our color at the bottom, it changed both of our the color in both plots.
Ah, good.
So we might want to show the key and how we can lock that graph down.
Okay, so I believe I'm on pack weight up here. So let's pull the key down and hit lock. So if you click on key and hit lock, we don't need to see the color gradient, so I'm going to hide that. And now when I click off of pack weight, notice in this card here, it's not changing in that first plot because it was locked, but it is changing in the second one. Now, what I want to graph in the second graph is the absolute value of all these differences. So now we're taking all the guys that were on the negative side and throwing them over to the positive side and saying, okay, let's really look at this plot. And the colors are different, so we're good. I'm going to pull in the divider tool and say, what are we looking for? We want to find the mean absolute deviation. Well, the mean is the center clump. So visually, maybe something like this would be our center clump of all of these differences. And the differences are now all positive. They're how far we are from the mean. So before we get too far up here, I want to have this visual for the students and saying, okay, what do you think the mean absolute deviation is going to be? So they're estimating, well, it's going to be somewhere between 5 and 6, maybe closer to 6. Let's go up here to this plot and click on the ruler tool down arrow and show that we can actually turn this to mean of the differences. So I'm going to, before I do that, I want to clear this. And now I want to click on mean of the differences. And it just takes off and it runs. And we see the mean of the differences is 5.31. An intermediate step there would be to find the sum of the differences with the absolute value selected, and then click measure all, because that's going to give you the total of all of the differences. So I'm going to click here and click measure all. So again, part of the calculation there is the 117 divided by 22 gives you what? And that we already saw it was 5.3. Let's go down here to our bottom plot and actually show the mean and show the numeric value. And it's 5.318. So now I need to pause again and check to see if we have any questions. And if there's anything that I need to go back through. I tend to get nervous and talk too fast, so let me know how my speed is here.
I think we're doing good, Kathy. One question was two different colors, and I think that's, since we're looking at numeric attributes right now, we're seeing the gradient pop up. So I'm not sure if the question from Leslie was about two colors in one graph. So if we clicked on like gender, for example, we're going to see different colors, whereas in the other graphs we're seeing the gradient because we're looking at the numerical attributes.
Oh, that's a good question. I'm glad that came up. So let me click on grade and talk about this real quickly and just kind of showcase a little bit of the features of TinkerPlots. The grade for this data set, we dropped out the first and third graders, so now we just have fifth and seventh graders. This grade attribute is categorical data. So you will see distinct colors, and what you can do with your categorical data is use rectangular to get your bar graph, or you can use circular to get a circle graph, and you want to actually have that as one circle graph. So let me order this So we get the circle graph. And here's where you would want to turn your key on to see what your colors are. But categorical data is going to be color-coded with distinct colors. If I mix this up and click on name, you'll see all sorts of different colors because name is also categorical data. Everybody's name is distinct, but they're categories. And gender is also, but we don't have any boys. We'd have to go back up to the original data set. So we'll see that some more as we go back to the full data set and talk about mean absolute deviation. What's happening here with pack weight, because it's numeric, we get a color gradient. And if I open this key all the way, where's my arrow? There we go. We see the range is from 3 pounds to 27 pounds. Something else that I want to make sure I talk about tonight is the fact that you can actually add the units here. So we could actually put pounds in here, and it will show up on the graph. And it should show up on the graph, but that's not the right graph. Let me go to this one. Now you see why I want to get rid of a couple of those variables. So now we have pack weight, and we have our unit in pounds. Other questions that are coming through. Are you guys finding, I guess what I want to know is, are people finding this helpful? Is this something that you guys would be using with students? So I guess that's where I'd like to kind of see what kind of feedback we get there. Mean absolute deviation is showing up in the 6th grade and 7th grade Common Core standards. So I'm trying to make sure that what we're doing tonight is relevant. Can you put the formula up in a text box to be able to show the connections between the parts of the formula and what you're doing in the table and the graph? I can actually open this up, I think, wider so you can see them. And, well, that one doesn't need to be wider. But can I put them in a text box? I certainly can. Let's go ahead and do that. If I copy this and close it out and pull down a text box, let me know if this is what you're, well, that didn't work. Usually my copy paste works. Well, what did I do? I had pack weight minus the mean of the pack weights. And then we took the absolute value of all of that. So here, let me see if my copy paste works. And maybe brackets would work better there. So, Shannon, is this what you were asking about? Putting the formula up in a text box? Can you show standard deviation and variance? Yes, you can. It's there. There's actually a lot of power to TinkerPlots, and I was going to just kind of wait to see if those questions came up, because a lot of people would like to know how to find those values. So let's put variance here. The problem is it's going to fill the whole table, so I'm going to get the variance all the way down for all 22 students. But other than that, I mean, it's going to work. So var, we need to go down to statistical one attribute. Here's your variance function, so double click. Notice here that it's giving you some directions, so a little mini help menu. So it's telling you what you need to put in here. It's telling you what formula it's using for variance, which is very nice to know because there are different formulas being used. So what do I want to take the variance of? We want to go back up and use pack weight. So double click here and click apply. Make sure things are, you're not getting an error message over here. And click OK. So there's your variance. And again, for standard deviation, we can find that. Again, we're going to go down to one variable, and now you have to decide which standard deviation do you want. Is it a population or is it, where am I looking? So you have S here, you have sample standard deviation, and you have population standard deviation. I'm going to go with population. And again, go up and put pack weight in. So there we do. There we have it. So yes, you can do these calculations within the table feature. If there's another way to do that, I apologize to the developers of TinkerPlots. I'm not aware of it. So I apologize to the masters that created all this great stuff. Looking at the data and the variance looks the same. So Payush, hopefully you're happy with what I just showed you. That's, I think, about the best I can do right now for where this discussion is going. So thank you for your kind words. Okay, so let's push on to part 3. And I'm going to minimize this table. And I'm going to minimize.
Kathy, as you start to minimize, can we recap on what we have up here on the screen before we move to the final part here?
Go ahead. Can you recap for me here?
Well, I mean, open our last picture back up there. We saw our plot, the bottom plot that we had there.
Open this one back up. Okay.
So this was showing, we were doing, I think, our color. Can you click back on our absolute difference in our case table on the left there? To get our colors back. So we were showing that mean of the absolute differences to be 5.3, and we thought that before you clicked on the mean for us, we assumed that it was somewhere inside of that gray box there, and 5.3 did fall in the middle of what we were thinking might happen when we looked at the absolute difference.
Yes. Oh, okay, I see what you mean, because I kind of snuck up on it here, but I didn't make that connection real clear. Thank you very much. Thank you. Good, good. So I just ran this again to show the mean absolute deviation from TinkerPlots, from running the function with the ruler tool, and then the graph below. Something I did read in the directions in the help menu, let's see if I can remember what I want to do here. I'm going to unstack this and order vertically, and let's move this out of the way. This might be a nice visual for your students as well to show these different bars. These line segments actually have, you know, the magnitude of that difference. So let's clear it and run this through one more time and show how that builds. So it's kind of a different graphic showing the line segments. This is kind of a precursor, well, it is a precursor to finding standard deviation. So I'm going to break from this section of finding mean absolute deviation, and we're going to go back to our full data set. So, and one of the features that I have on tonight, notice that I can drag this across the cases. If I go up to the window menu and have it on auto tile layout, I can't do that. And this is what the default setting is. The default setting is going to push things around, so you're kind of limited in your screen space. So I typically turn that, toggle that off, so it says scrolling overlap layout. So just some tips and tricks about TinkerPlots here. So we're back to our full data set. Let's mix this up and start. I'm going to shrink this because I'm going to get confused. Let's look at pack weight, and let's start with a line plot. So I'm going to separate and stack. And let's split this out by gender, because it's probably more interesting to look at. And we said that, well, there's really not a lot of difference in the variation. And we looked at range and interquartile range. Let's go ahead and find the mean absolute deviation for this data set. And what's the first thing I have to put in? I have to put in the mean, because we want to find the deviation from the mean. Then I'm going to put in my ruler. And what do I do next? I'm going to snap the ruler to one of the means. So notice that.
And Kathy, when we snap the ruler, we visually are seeing a circle put on whatever data is that we're trying to reach. So I didn't know if in the audience if they're seeing that or not. But as you hit that point, it will. When you say snap, it's making a circle there.
It's making the circle there, and it's actually, yep, it's actually attaching. The ruler is attaching itself to that case or that icon. And if you select it and click on that icon, it should show up in your card so you can actually see what student that is. So I'm going to hit next just to show you it's going to go to the next value, but then I'm going to hit measure all, so don't blink because it goes pretty fast. So not only can we find the mean absolute deviation of one attribute, it's going to split it out by 2. But right now we don't have the mean absolute deviation because I didn't select it yet. I have the sum of the differences of the 39 cases, and because they're positive and negative, that came out to being 0. So I need to click on the absolute value of the differences, and that gives me the total of those distances. And if I click, I'm going to clear it because I want it to run. If I then go to the mean of the differences and run it through, it's going to give me those values. And look how close they are. So when we said there's really not much variation between these two sets, we were right. It's really very, very close. So that's kind of boring. So let's put up grade level. So again, you're going to see categorical data. We have all the categories, and they're not in order, so I'm going to drag the label down and this one down. So now they look like they're in order. And because it was already set to run the mean of the absolute value of the differences, they're all here. So that's kind of nice. Let's clear it and just run it just for giggles here. So what observations can people make here? If we were to talk about the 7th grade Common Core standard and say that we have to talk about variation between the different groups here by multiples or factors, I'm sorry, as factors. Which group is a factor of which other group? Well, it's not very easy to see visually right now. So let's go back up to our hat plots, and there's a couple that I kind of snuck over at the beginning of the webinar. We talked about the percentile and the range hat, but we didn't talk about these two. The average deviation hat plot is now going to appear, and it's going to be something that is very helpful in this discussion. -1 or -1 to +1 average deviation hat plot is giving us this range on the positive side and the negative side for these mean absolute deviations. Let's focus on the 5th grade, which is the deviation of 4. It's a nice integer value. And I might not be able to do that. Nope. Because this is attached to the 7th grade mean, I don't think I can move the ruler down. I think I'm stuck with it being up here. I can move the ruler up here, and we can see the 5.8, but I can't, if I move it down here, it's going to mess up all the calculations. So I'm going to have to start it over on a 5th grade mean. So sorry about that. I thought I was going to go for the 4, but I'm not. Here we see the 5.8 to the positive side. If I drag the ruler over to the other side, what do you think we're going to see? We're going to see 5.8 below. This is very similar to what we would see with plus or minus 1 standard deviation in a normal distribution. And students, at least the students that I teach, get very confused with that. It's something that's just very abstract and they don't really understand it. And I'm hoping that, by using this tool with TinkerPlots, that my students will actually understand what this -1 to +1 average deviation is actually showing them. So I'm looking to the chat pod. We're looking at 7:51, so we only have a few minutes to kind of wrap this up and see what kinds of questions people have. I'm going to keep talking for just a few more minutes here. If we look at the mean absolute deviation for 3rd grade, how does that compare to 5th grade? How does that compare to 7th grade? 1.3 to 4, 1.3 to 5. We should be able to come up with some ratios. 1st grade, 1.7. Let's look at 1st grade. If we round the 1.7 up to 2, we round the 5.8 up to 6. 2 to 6 is what ratio? 1 to 3. So is the variation 3 times as much between first grade and 7th grade for the backpack weights? So just another way to talk about variation, in addition to range and interquartile range, is your mean absolute deviation. Questions or comments? I have one more poll that I'm going to throw up, and I'm going to ask the question because it's a very generic poll, and it's one that we put in there not knowing where we were going to ask a question. So the poll is going to say choose a response. So you get the response, I agree, I disagree, or I have no clue. But the question is, do you see yourself using this type of lesson or something similar to it with your students? So I'm going to launch this. So do you agree or disagree that you would use something like this? If you had TinkerPlots, would you be using this? I'm just curious. And, you know, be honest, there's no names attached to what you're saying. 58% of you have voted. Let's be brave. You won't hurt my feelings if you say no, but as somebody who's working on developing some curriculum for TinkerPlots, I'd like to know if we're kind of going down the right track here. Okay, so 3, 2, 1. Vote, please. All right, I'm closing it, and I'm sharing. So quite a few people say that yes, they would do a lesson like this one if they had TinkerPlots. So thank you. And I'm going to hide that, and I'm going to pass the baton back over to Elizabeth and let her wrap things up here.
Probably help if I unmute myself. Can you hear me?
I do
my office mate is attending the webinar, so she gave me a heads up that I was still on mute. So sorry about that. That was a fantastic webinar, and I'm I'm a little overwhelmed by the level of the math that is being asked of 6th and 7th graders and even 8th graders. And Leslie just commented that she can see herself using this as an introduction to statistics with her 12th graders. So that's an interesting idea. We also do have Fathom, of course, which is kind of designed more for those upper high school students. And Shannon says she's very impressed with the visualization. Yeah, I agree. That was wonderful. I wanted to show everybody our webinar page. We have now posted the upcoming TinkerPlots webinars. So September 13th and September 27th we'll have, I think, and Kathy, you'll be doing involved in both of those, right?
Yes, I will.
Fantastic. So you can register here. We'll be having Tech Tuesdays, every Tuesday, a technology webinar featuring either TinkerPlots or Fathom or Sketchpad. Just to let you know, next week we're having a special 5th week webinar. Since we had our extra Tuesday and Wednesday this month, we're having a special Sketchpad webinar on geometric functions. And then September 20th and 21st, I'll actually be doing a webinar using Sketchpad and looking at slope in the middle school. So that for those of you that are middle school teachers or teacher educators of middle school teachers, I would welcome your attendance. We have the question about how you get TinkerPlots. So if you go to our website, www.keypress.com, and you'll see a link for TinkerPlots. And you can download TinkerPlots directly and use it for 20 minutes. And if you want to, if you love it so much that you want to use it for longer than 20 minutes, you can pay us, and you will get a registration code that will allow you to use it as much and as often as you want. So I think we're running up against the end of the webinar here. If there are any, wow, I would use it for professional development for my teachers back in Ghana. That is amazing. I love that we get international attendees at these webinars. It's really wonderful. So thank you all for coming. You'll be getting a certificate of attendance through your email in a few days that you attended this webinar. We'll be posting the video of the webinar by early next week on our webinar archive page, which you can find here. And thank you so much, Kathy and Mark. You guys are pros, and that was a really wonderful webinar. I actually learned quite a bit myself. So thanks again for presenting, and we will see you both back here next month for the TinkerPlots webinars.
Thanks, Elizabeth. Good night, everybody.
Okay, good night, everyone, and good morning to some of you. Okay, bye-bye.